All right. So to solve this system right here, I'm going to go through the characteristics of which one I would use to solve this one. We're either going to use substitution, graphing, or elimination. What's the characteristics of this problem? How are they set up?
Standard form.
They're in standard form already, so if it's the first criteria of elimination, what about the second criteria of elimination?
Coefficient of 1.
Coefficient of 1 fits that. I actually have 3 1s up there. So therefore, I would think elimination would be the best. So I'll solve it by elimination first because that's the one I would choose based on the characteristics of the problem. All right? And so with that, standard form is what I'm looking for, and they're already there, so I don't have to move anything back and forth. And I've got a coefficient of 1 right here, so I could eliminate the x if I want to. But I can also eliminate the y, and I don't even have to multiply anything to it to get it to cancel out because it's a 1y and a negative 1y. So if I combine those two by adding 5x, no y's, and 5. Okay, then I divide by 5. X equals 1. Then I can substitute it in. I'm going to use the positive one. That. Oh, sorry. See? Little mistakes. There you go. By moving the 4 to the other side. So my value is... Why do I write it in coordinate form? Huh?
That's where it intercepts.
Very good. That's where it intersects itself, and the point of intersection is a solution to the system. All right? And so next, I'm going to solve this by substitution. Graphing, which works, and most of you probably use graphing because you like it, is actually the longer version of the problem. All right, so for substitution, it doesn't fit the criteria that a variable by itself, but I do have the criteria coefficient of 1. So what I can do is I can move, I'm going to move this x over or this y over. All right, let's move this y over. And so I'm going to use this equation, and I'm going to substitute it in to this equation. Okay? And so therefore, this is going to become 4y plus 3 plus y equals 2. Why is substitution beneficial? Why does it help? Look at what I have up there, and why is it beneficial?
You can plug in.
What do you mean by that?
Plug in for the x and y.
That's the process of substitution, but what does substitution give me?
Answer.
I'm going to give you the answer. It gives me the same variable. I don't have 2 different variables anymore. Okay? So now I'm going to have 4y plus 12 plus y equals 2. Okay? And so now I'm going to combine.
Wouldn't it be with 12 on that side? 12?
I'm going to move the 12, yes. I'm going to move the 12. It's going to give me negative 10. Y equals negative 2. And now I'm going to do substitution again. I can even use the one up here that I created. Well, it should work if I do math right. All right. All right, and there's my solution of 1, negative 2. Yes? Yes.
C.
Last one, we're going to use graphing.
I think this is the one that I can do.
All right? So graphing here is going to be the longest version because are either one of these equations in y equals mx plus b form. And so I got to get them there, and to do so, I've got to do some math to move them. All right? And so, for me to do this top one, I've got to move the 4x to the other side. For me to move this one, I got to move the x, then divide by -1. All right? And so these are my new equations. Those are my new equations. Check them to see if they're good.
Hold up. How did you do that so fast?
Just did it in my head this time. But this one right here would be the one that'd be the hardest to do. But I'm going to subtract the x from both sides. That's going to give me negative y equals negative x plus 3. Then divide by -1.
Or do you divide every number by negative?
Every number by -1.
Yeah.
All right? So now, I'm going to graph it for you. All right, so I'm going to put this one in, negative 4x plus 2, x minus 3, graph. Can I see the point of intersection? Yeah, so I'm set up really nicely. Second trace, scroll down to intersect. Now, as I select the second curve, first curve is fine. As I select the second curve, what's the one thing I got to make sure I do?
Get on the other side.
The other side of it.
Of what?
The intersection.
The point of intersection.
And it's gotta be on the other line, right?
Yep. And so therefore you see 1, -2.